So Unit 2, Lesson 1 brings us to rate of change. Rate of change is fancy for, that's right, slope. So pretty much nothing new. Still reviewing some basics from Algebra 1. So when we model using functions, we are very often interested in the rate that the output is changing compared to the input. Fancy talk for if I were to pick 2 points. Say I were to pick this point right here and this point right here, what's that slope? Now, is that slope faster than the slope between those 2 points, right? That's the average rate of change. And in calculus, you will do instantaneous rate of change. But for now, let's start off with the simple. If I were to ask you to do f of 0, f of 4, f of 7, and f of 13, based on this graph, hopefully all now we would say, okay, when I put a 0 into function f, I get back the number 1. When I put a 4 into function f, I get back the number, what is that, 5, 6, 7. When I put a 7 into the function, I get back 10. And when I put a 13 into the function, I get back 15. So we have a new math symbol, and it really shouldn't be new. I think you guys used it in earth science. It is not triangle, but delta F. And I believe delta in Greek means triangle, if I'm not mistaken. So the average rate of change is simply computing the slope between 2 points. Here we are asking when x is 0, when x is 4, which we have up here. So basically, this is asking me for the change in y over the change in x. I don't know if you can hear it in the background, but there's some annoying little child out on the front steps banging on like a tin can. If I can find him and yell at him, I will. Or her. So anyway, the change in y means how do the y values change? Well, when I put a 0 in for x, out came a 1. And when I put a 4 in for x, out came a 7. So this is how I look at it. 1 changed into a 7. That means the change from 1 to 7 is a positive 6. The change from 0 to 4, what did I do to 0 to get to 4, was I added on 4. So this has a rate of change after I reduce of 3/2. And it makes sense, like that's my slope. Up 3 over 2. Up 3 over 2. And I end up being on the line. So for the next one, I'm going to go to, I want to see what my rate of change is between 4 and 7. So basically what they're asking me to do is they are saying, hey, we're going to look at this interval right here. We're going to look at this interval from 4 to 7, and we want to see the slope. So once again, this is the point 4, 7, and this is the point 7, 10. What did my y values do? From 7 to 10, I went up 3, and from 4 to 7, I also went up 3, giving me a slope of 1. Up 1 over 1, up 1 over 1, up 1 over 1. It does indeed check out. And as you can see, the last 2 points, same thing. We are going to expand this. And we want to check what the slope is between those 2 points. When I put a 7 in, out came a 10. When I put a 13 in, out came a 15. What did 10 do to get to 15? I added 5 on. What did 7 do to get to 13? I added 6 on. So that is a slope of 5 over 6. And if I check myself, 1, 2, 3, 4, 5, up, 1, 2, 3, 4, 5, 6 over. So now we are going to look at two functions, 5x plus 7 and 2x squared plus 1. And I have them in Desmos. That's what I did. I'm going to go back and use Desmos in 2 seconds. But just to show you that you should instantaneously know now in Algebra 2, before you even see the picture, that that's a line because it's in the form y equals mx plus b. And you should understand that this is a parabola because of the highest degree being a 2. And that it is a plus out front, so it's a happy parabola. It's smiling at us. Calculate the average change for both functions over the following intervals. All right, let's go take a look at this on Desmos. So over here on Desmos, we have it, and I'm going to change both of these to charts, which would make it real simple. So the first one they want me to do is from -2 to 3. So I can just come over here, and when I put a -2, I get a -3. And I don't have 3 on here, so all I have to do is type in 3, and voila. So my y values are -3 and 22. So I'm just going to come down here, jot them down real quick. -2. Look at that. Mind of a sieve. Let's see, -2, -3. And 22. And while we're at it, let's get the 1 and the 5. So the 1 is 12 and the 5 is 32. Now I'm going to do the slope real quickly. This is how I do math in my head. I'm going to invite you into my head. It's a scary spot. But how far is it from -3 to 22? This is actually what I see. Here's -3. Here's all powerful 0, and it is all powerful. And here's the number 22. Well, the distance from -3 to 0 is 3, and then from 0 to 22 is 22. That's how I learned to subtract. So that is a distance of 5. So I know the change in y over here is, sorry, not a distance of 5, is 25. Now, how far is it from -2 to 3? That is 5. All right, all I have to do is change my mindset. There is -2, there is 3, that's a distance of 2, and that's a distance of 3, I get 5. So my slope for my red line at this given interval is 5. Now, guess what? It's a linear equation. My slope better be the same no matter what 2 points I check. So from from positive 12 to 32 is 20. And from 1 to 5 is 4. So yeah, it is great. I get a consistent slope. Now, however, with my wonderful quadratic, things are going to be different. So first off, we need to put in the number 3 here and the number 5. All right, so when I put a 3 in, I get 19, and when I put a -2 in, I get 9. So 9 and 19. And then over here, I need to put in a 1 and a 5. I know my 5, I believe, was 51 when I put it in, and my 1 was 3. Again, doing my slope very quickly. From 9 to 19 is a distance of 10. From -2 to 3 is 5. So its slope is 2. From 3 to 51, wow, that's 48. And from 1 to 5 is 4. So that's 12. And we can see that a quadratic will have different rates of changes, different slopes, depending on what points you pick. So for this -2 and 3, we can come over here to Desmos, and we can see that if I go to a -2 in blue, which would be right there, and then I go to 3, and if you could imagine a line, not a bad little ski slope, kind of fun. But Imagine, I'm going to have to shrink this down. Imagine the slope from 1, too many dots, from 1 to 5, that's a slope of 48. And that is something I'd never ski down. Nope, never find me on that trail. Me no likey double black diamonds or black diamonds. I like to cruise on my blues. See you tomorrow.